Let's take a look at the operating characteristics of the motor here based on this nameplate and what we know. Okay, so a couple things. This is a 75 horsepower motor. So this is going to be a pretty big motor. I mean, a really big motor. It's running at 230 and 460 volts, okay? So that's the first thing that we need to know is voltage is 230 or 460. I think we're going to take a look at this running at 230 volts, okay? The RPM is 1780. Okay, so it's running just a little bit off synchronous speed of 1800. Amps is 175 or 87.6. Okay, so amps at the low voltage we'd be running 175 amps, which is a lot, or 87.6 at the 460 volts. So that's a pretty heavy wire that we're going to be running to this. It's 3-phase, 60 hertz. It's going to have a service factor of 1.15. So if we were looking, let's say, at the 230 volts, we could overduty this a little bit. We could take this 175 amps right here. Okay, let me get my calculator going right here, and we could take that and go 175 times 1.15. which is coming up to 201.25 amps. Okay, so that's called your service factor amps, where you might run a little bit over duty, and it is a continuous duty motor. All right, so it's a pretty big, hefty motor, and it'll run a little bit over the nameplate. Here, it's certainly going to run hot based on it'll run in a 40 C. And I don't see my insulation clash on here, but that would tell us where we're how much how hot this thing's going to run. So like I said, it's pretty big hefty duty motor. The other one I'm seeing is because it's a enclosure is a totally enclosed fan cooled motor, so there is no vents or anything on this. This just has a have a fan that's cooling it. It's a motor G. So if we go and we look at our kVA per horsepower, it looks like it's a locked rotor amps of somewhere between 5.6 and 6.3. So, you know, roughly 6 on a locked rotor amp. So we were taking a look at this 175 amps right here, and we multiplied by 6. You're going to get a pretty big number right here. 175 times 6. You're going to get over 1,000 amps. Okay, locked rotor amps. So that's the situation where if the motor gets locked, it can't turn, and you get the spike in the inrush current that we had talked about right here, and for some reason you're not able to come down to steady state. This inrush is going to be very high, and it's going to shoot right off the charts there, up to 1,000 amps, and any kind of circuit protection that you have on there is going to trip. Okay, so and that's going to be pretty heavy duty circuit breaker and circuit protection involved in this motor, because this is a big motor. Okay, so that's kind of how you read some of the things off of this nameplate, specifically the service factor amps. You multiplied by 1.15, and you want to keep that in mind when you were sizing the continuous or steady state circuit breaker and circuit protection, and also the locked rotor amps is what you'd want to keep in mind when you're doing your time delay here as well.